April 29th, 2020. Our speaker for this evening is, I'm sorry, I'm having trouble navigating everything. Our speaker for this evening is Mr. Ganesh Kasari, and again, who is on a mission to simplify data science and help everyone understand its true potential. Our moderator for this evening is going to be Dr. Lilia Pavlovsky, who is an assistant teaching professor and director of the MI program at SCIEN. So here's how tonight's webinar is going to work. As attendees, your camera and microphones have been disabled. Chat between participants and the speakers and the panelists has been disabled. However, Q&A has been enabled, and we really want to focus and send all of your questions through Q&A. So what you'll do is you'll please submit your questions by clicking on Q&A in the Zoom command menu and typing in your question. No anonymous questions will be allowed, and Dr. Pavlovsky will be monitoring all your questions and will choose which questions will be answered live during the broadcast. It's possible that not all questions will be asked or answered during this broadcast. So with that, and with no further ado, I'd like to turn the meeting over to Dr. Pavlovsky, who is going to say a few words and introduce our speaker.
Thank you, Connie, and welcome everyone to the Colloquium. I hope you're all safe and healthy and ready to learn something today. And perhaps you're getting ready to move on past this Corona world. Let me tell you, I am. However, we're going to be making the best of the situation, and I'm really thankful that we have technology as we do today to make events like this possible despite the circumstances outside. It's hard for me to believe that the Master of Information program is only a few years old, since we only launched it in this particular configuration in 2016. Our goal was to expand our LIS community to include students from other information professions, especially those people, excuse me, who are interested in technology, data science, management, and those types of related areas within the information professions. And this is a sector within our program that continues to grow. Over the past few years, students have come up to me and asked if we could improve our programming for their purposes, for their goals, and to maybe not improve, but to include topics in colloquia that are related to data science. And so I am so happy to say that Ganesh Kasari is here to talk to us about this topic, about data science and its value to organizations. Ganesh is a co-founder and head of analytics at Gramener. It's a data science company. He helps transform organizations through advisory, in building teams, and adopting the culture of data. He's a TEDx speaker, global corporate trainer, and author, and really a great speaker, actually, and a great guy. Welcome, Gaines. It's so wonderful to have you here.
Yeah, thank you, Dr. Pavlovsky. It's my pleasure to be here, and thank you, Connie, for organizing this. So let me share my screens and we can get started. Hi, everyone. Excited to be here talking to all of you. Let me share my screen. Yeah, hope you're able to see my screen. Yeah. Yeah, you can see my screen. Can get started.
I can see it, Ganesh.
All right. Yeah, thank you. Hello again, everyone. So the topic for today is reality check. What's the value of data science for organizations? A couple of months back, when we finalized this topic and planned this session, things were a little different then. One, we were planning this as an in-person session, and I was looking forward to being on the campus. I'm thankful that we are able to go ahead with the plan and have this online. And number two, we were planning to talk about a few things, and now in the last month, priorities for the entire world has changed. We're talking about COVID-19, we're talking about a recession. And so given this context, actually this topic is all the more relevant today than it was a couple of months back. And in this session, you will learn three things. Firstly, you'll understand the real value of data science for organizations with a lot of interesting industry examples. And you will hear about some seemingly not very obvious things in the industry, things which people don't expect, certainly not people who are coming into the industry. And when you understand this, and how do you turn it to your advantage? How do you not just survive, but thrive in the industry? And third thing you will learn, what does recession mean for the data industry? We'll tackle the question head on. What does it mean for the industry, and what does it mean for your jobs? So that's the objective for today. And Dr. Pawlowski already introduced me. So I'm Ganesh, I'm from Gramner. At Gramner, we solve business challenges by using insights and stories. Data analytics and visualization are the focus areas. And I'm very passionate about simplifying data science. Before we get started, I'd like to run a quick poll to get a pulse of the audience. And so let me launch the first poll. And you would be able to see the questions on your screen now. So the question is this: what's your level of familiarity with data science? Just trying to understand the mix of the audience here. I know we have a very diverse set of students. Are you familiar with data analysis, statistics, machine learning algorithms, advanced techniques like deep learning, data visualization, storytelling? Yes, there's a difference between the two. Or you are new to the industry, just you're here to learn, which is the last option, which is absolutely fine. I see some votes coming in. We'll give it a few more seconds. And by the way, we will have a couple of more polls at the end of each of these sections. And so you would be able to ask questions anytime. So please do go in and raise your questions, put in the questions into the box. And either during these times when we are taking the answers, the polls, we can answer them. I'll answer them, or we can do it towards the end of the session. So please do raise your questions. I'm not, okay, I'm seeing some responses. I'm not sure if all of you are able to look at the questions and are able to answer them. I see a couple of, okay, I see some questions coming in. Okay, the poll shut off, okay. Let me see if there's a way to keep the question on.
Unless you can relaunch the poll.
Yes,
Let's try it again.
Yeah,
they're saying that it shut off too quickly.
Yeah, I've kept it on. All right, yeah, now I see the responses coming in. Okay, so far data visualization seems to be popular, data visualization and storytelling. And we have exploratory data analysis coming up quite close to it, machine learning. And I've been looking at the backgrounds and the kind of students for this MI program. It's very fascinating to have a very diverse bunch of students. And particularly for the examples here in this session, I've taken a mix of enterprise and otherwise. So with this, I think we've got over 40 responses. And let me share the results back so you can also take a look. Data visualization is top, followed by storytelling and exploratory analysis and statistics. All right. Okay, so with that, let's get on to the first part of the topic. So we'll talk about the value of data science for organizations. But before that, full disclosure, the industry has a big problem. We are used to too many buzzwords. And people say even data science in itself is a buzzword. What does it exactly mean? And we have artificial intelligence, augmented analytics, you name it, there are enough examples. And marketing has been pushing this industry ahead, and it has given us its fair share of buzzwords. And these buzzwords spill over into the titles that you find in the industry. And that's equally confusing. What does a data scientist really mean? A lot of organizations use this title, but the job roles are completely different company to company. And there are a lot more titles. And as an early takeaway and a bonus for this session, I've put together a custom data science title generator, just for some fun. So you can generate custom titles by stringing together three things: some vanity keywords, areas of focus, and some job activities. What are the options we have? So vanity keywords like chief, principal, as important as you want it to sound. And areas like data, statistics, ML, and activities, you can make it as clear or as vague as you want. Either engineer, analyst, or wrangler, ninja, can mean anything. So now let's look at a combination of titles that is generated. senior data scientist. That's quite common today and sounds meaningful. What about principal AI storyteller? AI is popular storytelling. People love it. Why don't you string both and put in principal to make it sound important? And how about chief data wizard? Sounds even more important. It comes with the added advantage of people not having a clue what the job type, what the job responsibility is. So if you're wondering how organizations are grappling with these buzzwords, ask an executive who has burnt their fingers putting budget into some buzzword. So big data, and there are enough examples. So that's something for us to think about, and we will answer some of these during the course of the session in terms of how you can understand the real meaning of some of these terms and what are the real roles needed on data science teams. The journey from data to decisions is like this. You start by collecting the data and you curate and store it. And then you transform to make sure that you have a single source of truth in a single location or in a data lake. And once you have the data in place, you go ahead with reporting, looking at simple summaries to understand what's happened in the business yesterday. And simple aggregates, MIS reports, KPIs, we're familiar with these. But for deeper insights, you need to go into analytics. You need to get into statistics, machine learning. And insights are what extract better essence from the data. But what use are insights if no one consumes them? Data scientists often throw the statistical model outputs to business users who just ignore them. So consumption of insights is very important. Could be through visualizations, through stories. Consumption is very much a part of data science. And once you understand what has happened, why it has happened, and you have a full understanding of it, the journey is not complete. You need to take a decision. You need to come up with an action. That's when you complete the cycle. So as data science professionals, it's our responsibility to enable decision making by providing some business recommendations. So this is the journey from data to decisions. So the three phases which these fall into: data engineering is phase one. Data science is where making sense of the data and extracting value from it. And when the entire organization is able to use data for decision making, that's when we call data as a culture. An organization has embraced data as a culture in every single decision making within the organization, not just the market facing functions, but HR, support functions, and every single internal decision also is based on data. And one other interesting point here is you see this is the left to right journey, and organizations push maturity levels upwards. What happens when you go to the higher levels is that there is a pull effect which is created in the reverse. An organization which is in data science, deploying machine learning, starts asking for better quality data, more data. So there is a boost to data engineering efforts. And when data becomes a culture, your employees and the people start asking for more insights and for more channels of consumption. So data science gets a boost again. So that way there is a push when you go left to right. And as you mature, there's also an improvement happening on the upstream areas. So we'll now look at examples which fall into these four categories: reporting, insights, consumption, and decisions. Very interesting examples from different industries. And then we will talk about how they are created and what are the rules which are essential to create these insights. Reporting is the first one. Descriptive summaries we've seen. And this is something which all of you are familiar with. Simple Excel reports, tables, all of these have been around for decades. This table shows the revenue numbers from 4 cities. And this seemingly ordinary looking table is actually a special one. In case any of you have an understanding of what this special table is about, do put in your message on the chat window. Yeah, I would like to know how many of you have an understanding of the pattern that you see here. This is very, very unique. By the way, coming back to reporting, it's very common. So now let's go on to insights. So there was a global telecom player who was interested in controlling customer churn. So we worked with them, and they gave us the data in terms of the talk time and the bill values and the domestic versus international calls. All data about the customers is available. we analyzed that to find out some interesting patterns within the data. And we wanted to find out what drives the customer behavior. At what point do they move out of this telco player? And what are some early signals that they leave? We did a variety of modeling, simple to complex ones. I'm going to show one result here. This is a fairly simple, explainable model, which asks 3 questions. And with those questions, it tells whether a customer will churn or not. First question is the tenure. How long has a customer been with you? If the person has been for under 12 months, low risk of churn. More than 36 months, in this situation, you'll have to pay attention to the person. Anything in between, this is the second question. For those who are 1 to 3 years, what was the last bill value? Was it over $65? If yes, low risk again. If not, we have a third question. What was the data usage? Was it more than 1.5 GB? If yes, you're safe. Otherwise, you need to take some action. So with this, you can actually bring it down into certain business rules and say that anyone who doesn't fall into this path, those are the customers you have to maybe run some promotions and take up some retention efforts. All others are fine. It can be very, very targeted and very scientific. And this model, which is simple and explainable, gave us almost a 30% reduction in churn, which was very interesting. And the business team was very excited because what they had earlier was a heuristic, very crude approach. What we found later on was when we looked at even more advanced model, like neural networks and other advanced black box models, they improved the accuracy even further. The churn was brought down by over 50%. So the decision point now was, are you okay with a simple, explainable, but relatively low accuracy model? Or do you want a more complicated black box model, but it has a better accuracy? So this is a common decision point in machine learning. The insight is very powerful and can help you retain customers. Second example is from satellite imagery. Organizations collect data painfully through door-to-door surveys. It could be for demographics understanding the education level of people, wealth levels, or looking at the quality of infrastructure, and in some developing countries, the access to clean water or other facilities. So this is done through sample surveys or a national census kind of exercise that is very exhaustive, takes years together. What if we can use analytics to identify these parameters purely from satellite imagery? Is it even possible? We tried this and we found the results very fascinating. We trained an AI model, a deep learning model, which can understand images, the high resolution satellite images. By looking at the patterns of the kind of buildings which are there in the map, it was able to find out that there was a pattern to the wealth levels, to the population densities, and even to other not very seemingly obvious factors. So we put together an interface. This is available in the public domain. I've shared all these links here in the deck. So you can point to a particular latitude, longitude, or choose a city, and then you can find out what the model says about that location. For example, when we look at wealth levels, when you pass an image like this from the map, the model is able to come up with these grids. It says that these are the grids, and those 2 locations you see, they are the richest. And all others fall in the rich category. You don't have any in the bottom 3. This is a major city in India. And when we ran this for other locations, we were able to find that the results were fairly accurate. They were very reliable. And we were able to identify other factors, not very obvious ones, like the access to good toilet facilities and access to water facilities. So all of these purely from satellite imagery is possible today. And there's actually one work going on today where we are using this for flood response. Can you study the rising water levels from the map and rush the emergency response teams to those locations which need it most without waiting for an incoming call? And that's a actual engagement which is going on using a model like this. So now let's talk about consumption. So these 2 were the insights examples. If I ask you the question, when are people born in the US? Are you aware of any patterns? And those who know about it, please do type in the chat window. Are people born in the weekends? What about the holiday season? Do you know of any patterns, any guesses? Please do type in. Yeah, happy to understand what you think. We looked at a couple of decades of data in the US, and this is what we came up with. So here we have this laid out on a calendar, the cells which have darker colors mean more births and lighter shades are fewer births. And it's laid out Jan to December, 1st of the month to 31st of the month. And you start seeing patterns immediately. When are most births happening in the US? In September, which means the conception season should be the holiday season. While that happens, there's also another pattern in the holidays. Not too many births happening during the Thanksgiving and Christmas holidays. Maybe the health professionals are busy holidaying. But there's also a pattern involving parents. Maybe the parents don't want their children to be born on the April Fool's Day, April 1st. And they consider 13th to be unlucky. You see the entire column showing low births throughout the year. But 14th of April seems to be popular. So these are some interesting patterns. And by the way, if you're wondering how is it even possible, given that a majority of the births in the US are C-section, it's possible to move it by a couple of days. And that's where you see those movements happening away from 13th to 14th and so on. So this is fascinating. And we did the same analysis for India. When are people born in India? Is there a pattern which is very different? You can see that it is completely different. There are very few births in the second half of the year, August onwards, and a lot in the first part, particularly in May and June. Now, when you look at it statistically, this is a little confusing because you can't, we talked about how you can move it by a couple of days, you can't move births by an entire month. So something seems to be wrong here. So we also noticed that there was a striking birth pattern for 5th, 10th, 15th, 20th, 20th. Every month you see that pattern, you see those dark shaded columns. And we also do fraud analytics for our customers, and we sensed something was wrong. And this data had to have some external influence. In other words, there was some fraud happening behind the scenes. Why would you have this in birth dates? Right? If you're curious, another piece of insight for you is that the school year in India starts from June. Any kid who's born after July misses the school year and until the next year. So parents, until a few years back, it was easier to modify the birth dates after the kid is born. So the birth dates were artificially changed in the school records. And that's what you see in the mark sheets. And by the way, now they've made it a lot more stricter, but this is the pattern you see here because this birth pattern is from mark sheets. Data can tell you a lot of stories, and you can make it very interesting and fascinating to consume it. How about a completely different area? If we go into literature, can we apply visualization and look at how Shakespeare's sonnets look like? It's very fascinating for people who are from the literature background. You might find this very interesting. We did this purely for fun. We took up Shakespeare's sonnets, the 154 sonnets, which fall into different categories. And we started looking at what are the words which are used there? What are some patterns we can find? So this is what it looks like. Each of these boxes are the sonnets. You have 154 boxes. And each of those lines you see within the boxes are lines of poetry. So you can hover over them to find out what the line is about and can read through that. And also, when you look at the categories, there are several categories like procreation, fair youth, dark lady. And it will be interesting to explore what kind of words do they contain. And if I search for love, for example, a popular theme, you see that it appears in a lot of sonnets in this full list. And now I can further go in and look at, say, one category like dark lady. Which sonnets, which verses have the words which contain love. So you can explore this interactively. And we wanted to take this further and create a word analysis, a layout, network layout of each sonnet. So we converted each sonnet into a visual. And by stringing the words together, so here we have the first sonnet goes like, from fairest creatures, we desire increase. And now each of these circles are each of these words in sequence strung together. And the color is the parts of speech. And now you can see that there are unique words used. Wherever words are repeated, it gets branched out. So might occurs twice, you see that branching out. And with this, you can understand which of these words are generally unique and how convoluted is a sonnet. And another thing which you can understand is how comparable are the sonnets, which are the most similar ones, purely looking at a word lexical analysis. And this is sonnet 1. And when you look at the numbers on the top, anything which is shaded in a darker shade means it is highly similar to the current sonnet, which is sonnet 1. You can see 77 has a 40% similarity to sonnet 1. So when you click on that, you can go and look at it to explore it. This seems to be a lot more convoluted than what we saw earlier. So this is a fascinating analysis. I know it's a little technical, but looking at vocabulary-based analysis and visualization to decode the sonnets. And this is also a public example. Feel free to play with it. So these two are examples where we looked at deep insight separately in consumption. What if you bring them together? Deep analytics, machine learning, and you enable consumption through a rich interface. This is the work we had done for the World Bank. The question which we were asked was, what is the relationship between innovation, technology, and entrepreneurship? If you look at the 150 countries around the world with a whole lot of parameters and indices, what can we tell? What is the relationship? So each circle you see here is a country shaded by the region. So East Asia, Europe, North America. So North America is the golden color here. So with this, we've created a storytelling interface. So you have the text explaining on the left-hand side, and there's an interactive visual on the right-hand side. So now when you start exploring it, now you've presented the countries first. And now when you start looking at an analysis to look at the favorability of the countries for innovation. And we applied a clustering algorithm to find out which of these countries are most similar. The most favorable group you see on the top are those set of countries which are favorable for innovation and are also similar. So you can see Europe, North America falls in there. And there are a few countries from Africa, a few outliers. And then there are these other least favorable groups. Now, if you look at further relationships, what is the relationship between innovation and access to technology? So the top right quadrant is those set of countries where there's good availability of latest technologies and the innovation quotient is very high. You can see most of these, the countries in Europe are there, and US is there. But Malaysia is a country which falls in that zone. And when you start looking at other aspects such as business and innovation environment, what is the relationship between the environment and innovation? And other aspects such as entrepreneurship. Is that a career choice? The box you see there are countries where entrepreneurship is a choice, but they don't have much of innovation happening. There are hurdles for people to come out and innovate. And so on. You can go on exploring and find out what are the insights, and these are called out on the left-hand side. And finally, once you read through all of this, you can play around with it finally by choosing the axis that you want and choosing the size of the bubbles. And now that you're familiar with the interface, you can discover your own insights and tell stories. So this is something which is created for the general public. They don't need to understand analytics. They don't need to create their own visuals. They can just play around with it, just like, say, a New York Times data story. So this is a good example of insights and consumption coming together. A final example is from data culture. When data drives the entire organization, like we've seen in the starting, that can create magic. What are the organizations which have done that? There are these technology majors, Google, Facebook, who have done it, and they are far ahead of the game. What about other companies? Which other company has a deep data culture? Good example is Netflix. So they started early in data, even before data science and all of these were buzzwords. So I'm not sure if you're familiar with the Netflix $1 Million prize. This was a prize for the recommendation algorithm. It was a public contest more than a decade back. And they have done a lot of innovations over time, not just in the market-facing activities such as the recommendation engines, but in a lot of other areas. Even content creation, House of Cards was based on data. And a lot of other internal activities are based on it. And even the thumbnails that you see for movies, no two thumbnails may be the same. The thumbnail you see, for example, for Avenger may be based on the characters, the actors that you like, whereas your friend might see a completely different thumbnail customized to the individual based on their unique preferences. So they have taken this game way far. And when you look at Netflix research, they talked about some of the use cases they are applying machine learning to. You can see the broad variety of use cases: marketing, fraud detection, classification of internal support tickets, translation, a whole lot of areas. And a good example of this is the recent innovation. During the lockdown, they launched a new feature called Netflix Party. Not sure if any of you have used that, but Netflix Party makes up for lost movie nights. So during lockdown, how do people come together and watch movies together with their friends? So you can get into this a common room, and the movies are synchronized and they play real time for everyone. And people can chat and share their expressions and have fun conversations remotely. And by the way, this is a brilliant strategy, because when you look at this, Netflix also collects all of this data. Now they know who are your friends. They know which parts of the movie they you like based on the comments which are coming in, and who agrees, who doesn't agree. So maybe the next set of innovation will come based on the data they collect from Netflix party. So this is a great example how organizations can integrate, and this becomes a strategic differentiator for companies in the industry. So that was the first section. Before we move on to the next one, let me launch the second poll. And I see some questions coming in here. Let me take a look at it after launching this poll. So this poll, the question is, what's your exposure to the industry? To understand your background, how many of you have work experience, and how many of you are from the data field or from other disciplines? And if you're from the data field, how many of you have a data engineering or a data science background? Okay, I don't see any of the open questions. I'll give you a few more seconds to answer. I see responses coming in. So most of you have experience in non-data fields, and some of you don't have prior work experience. And there are a couple of people with experience in data science. So I have over 75% responses. So let me end the poll, and you can take a look at the results. So this is the mix of this current audience. Let me get back to the deck. So now let's talk about the second section, which is reality check. What are some unexpected things that you will encounter in the industry, and how you can change these to your advantage? One biggest challenge which organizations face is that most data science projects they end up solving the wrong problem. This might sound fascinating because organizations invest millions of dollars. And why would they be solving the wrong problem? Look at this example. There was an executive who has gone to a technology conference. They hear about AI and its exploits and image recognition, understanding videos, writing articles. They get pretty pumped up, and they come back to their organization. They call the technology leaders and say that, so I have heard about AI. It's revolutionizing the industry. We want to be ahead of the game. So here's a budget for you. Go and implement AI for us. And they go ahead and hire PhD data scientists, and they buy certain tools. And then this team is running around the organization looking for a problem to solve using AI. When all you have is a hammer, everything looks like a nail. Right? So you end up picking an AI project, you implement it, but it may not be strategic enough. It may not actually solve a pressing business need which has to be addressed right now. So that's a challenge, not just when the project is started, even midway through the project. In every phase, this challenge persists. Let us take the example of, say, an analyst or a designer coming up with a visualization. So people have their own favorite charts, whether it is tree map or pie chart. I don't know if pie chart is still a favorite for anyone. I personally don't like it much. Sankey, some more complex visualizations. They want to try and put the data into it and see how it looks. So they kind of force fit the charts onto the data. And it's not based on a user need. It may not be relevant for the context. So the learning for you, and the first tip is that you have to master the application of knowledge and the concepts. You would have learned the concepts, but application of the concepts is an entirely different thing. And this is a common challenge we see in the industry. Let me give you another example. So let's say someone has learned business forecasting, the forecasting algorithms, and they've learned a variety of techniques. And now when a business person comes to them and gives them this problem that I want to forecast my sales numbers for next week or next month, and here's your data, how do you go about applying it? Scenario one, they give you just 1 week's data and ask you to forecast for the next 3 weeks. And I kid you not, this has happened to us. There was a prospect who approached and gave us one data point and said, we want the next 3 months forecast. And they said, use AI or whatever technique, and can you give us the forecast? So we took a long time to explain why it's not possible. So if all you have is a single data point, heuristics and business judgment can beat any analytics technique out there. if you have past 3 weeks of data, say 3 data points or a little more than that, simpler techniques can do moving averages, extrapolations, that is relevant. And when you have more volumes of data, then there's another consideration. What is the pattern within the data? Is it even possible to come up with a forecast? Because not every data can be predicted. So there maybe you have to look at statistics and simpler techniques. Whereas when you have 2 years of data with a lot of useful signals and patterns and seasonality and all of that, then maybe that's relevant to unleash the fury of AI on this data. And so this is the kind of question and answer you have to ask based on the data you have, based on the other questions you can ask about the context. So if you have to learn the skill well, what do? Here are some guidelines for application skills. So first ask, what's the business problem you're solving? Talk to the users and really make sure you understand it in non-data terms. Find out who is your audience. What are their preferences? What do they really need? And understand the user study and user-centric design is very important. And then you come to the data. So the first 2 questions, you don't even get into the data aspects. You have to talk about business, users. That's the starting point always. Whether you're starting a project, you're choosing a model, or you're building a visual, or you're just launching a product. So all of these, you'll have to start with the business users and the business problems. The next, you look at the data and what approaches are relevant, like in the example we just saw. Which insights are important and are they actionable? A lot of people come up with very interesting insights, which the data scientists get excited about, but they are not actionable. So assuming a business is in a certain line, and if the recommendation is to completely change the line of business, that's not going to be useful or actionable. So find out the actionability and take feedback along the way from your users and iterate. And repeatedly check for consumption, repeatedly check whether it's giving the business ROI, and go over this entire process multiple times over and over again. So this is a guideline for applying any skill that you've learned. And this is important because AI is coming for the data science jobs as well. So we are creating AI, and AI is going to take away most of the jobs within this industry as well. There's a lot of grunt work and stuff within the data science workflow which will become irrelevant soon. But application of the knowledge in a business context is something which will stay relevant for much, much longer. So that's one way to safeguard the job and make sure you stay relevant in the industry. So that was the first learning. The second discovery is that data analytics needs a lot more than data and analytics. No, this is not a play of words. Earlier, we saw the application of data analytics skills, but for delivering a project, a solution, there's a lot more needed than this. And that is the second tip for you. Pick up non-core skills. They may not be in core analytics, but these secondary skills will actually serve you very well. What are the skills and what should you learn? Let's take this example which we have seen earlier. This is a solution, the example we looked at. What does it take to put together a solution like this? What are the different components? What are the building blocks? There are 5 building blocks to create the solution. Number 1 is the domain. The understanding of the business. We looked at the influencing factors for innovation, entrepreneurship. That understanding of the domain is important so that you can create something meaningful, relevant for this target audience. Number 2 is analytics, where we looked at clustering techniques. We looked at the similarity between countries and impact analysis. Third one is design, where we have a beautiful visual interface. So it needs visuals and aesthetics. It needs understanding the user journey. What should be the sequence of insights? What is going to be an overload for the user? What is just about right? All of these come in from the design perspective. Development, front-end and back-end coding, transformation of data and pipelining the data to feed from the source to the solution is something taken care during the development stage. And project management to piece it all together and ensuring you manage the change well. So these are the 5 building blocks. And these 5 blocks translate into 5 roles that every data science team must have. What are they? Number 1 is that of a data translator. And this is the terminology which is used for the last couple of years. We've been calling it at Gramener data consultant for the last 10 years. And data translator was coined by some of these large management consulting companies, and it's picking up traction hopefully the industry will stick with this. This role is important to marry the domain expertise with the data skills. The person does business analysis, solutioning, doesn't have to understand the machine learning models in detail. An overview is sufficient. Doesn't have to be a design expert. Again, an overview is sufficient. A person should have a passion for data. That's important for every role which we'll talk about. For analytics, we have the data scientist as the most commonly accepted title, and that's the role where the person brings in statistics and machine learning knowledge, interpretation of insights in the business terminology. The person needs to understand more than models, and some scripting skills, because a lot of tools call for scripting, and deep learning calls for deep programming knowledge as well. Information designer fills in the design gap. This person is an expert in information design, user-centered design, UX aspects. And there are certain parts of interface and visual design which the person brings to the table. ML engineer, machine learning engineer, takes care of packaging of the data science solutions. Whether it is a machine learning solution or a visualization solution, it has to be encased in a shell. It has to be put onto the solution and integrated with the other tools. The ML engineer takes care of that, the software engineering, front and back end coding, and pipelining to the data. And a project manager, the common title is data science manager, takes care of project management aspects, also gets involved in business analysis, solutioning. It's not just a people manager, but also has a good understanding of data and is able to understand what are the different activities performed by his team or her team. And handling of the team aspects is important. So these are the 5 roles and 5 skills. So now a question for you would be, why do you actually need these anyone to pick up more than a single skill when you have 5 people playing 5 different roles in a team? So if anyone can take a guess, go ahead and respond. And meanwhile, let me...
Could you repeat the question again, Ganesh?
So the question is, when you have these 5 clearly defined roles and skills, why should the suggestion be to learn a secondary skill? If you are a domain expert, for instance, why shouldn't you focus just on your area? Why should you pick up a secondary skill, whether analytics or design? What is the need for it? If anyone wants to take a shot, do let us know, we'll unmute you. And this has something to do with the maturity of the industry and also certain things not being very consistent. So I see some response coming in here. Okay, the more team members, okay, this response, the more team members understand others' roles, the better they can work together. That's a very good response. And couldn't one person take more than one role? That's again possible. The team is also your audience stakeholders. So understanding some of their domain allows for better translation of knowledge from role to role. All of these are great answers. I think this is one part of the answer. Thanks for putting in your responses. One, team members need to understand other roles. So that way, if you pick up secondary skills, you will be able to communicate better within a team. That's number one. And the other reason, and one major reason for this, is that a lot of companies are still in evaluation stages. They are not very mature yet. Even today, you can find job descriptions where people club all of these skills together into one single JD, and they call it maybe a full stack data scientist. And they put that out as a position, one single position, hiring one person. That's the reality, and people are not looking at a maturity of these roles and in terms of what is the reality. So it takes some time, and the industry, there are many companies, thankfully, they have matured and they're looking at specialized roles, and that will happen. That will happen in a couple of years, but until then, you will see this mix happening. So that's one reason why when you attend interviews, when you are able to demonstrate little more aspects of these other roles, it makes you better suited for a position. And more than that, the point which you mentioned earlier, like understanding of each of those roles. And in data science, we have to come up with a holistic solution. You can imagine that compared to any other technology, here you're looking at completely different disciplines coming together. So for that, there has to be a lot of overlap in skill set, and which is why it's important to learn. And also, this is something which will make you indispensable. We have seen this time and again, both at Gramner and in other organizations in the industry. A professional who picks up more than, let us say, a person is from the domain background, so a data translator, they pick up design skills and become, they have an eye for design, are able to tell stories. So they don't stop at defining the requirements or collecting the insights. They're able to storytell, and they're able to respond very quickly. That strengthens their bond with the users, and they are seen as a hero in the eyes of the business users. And over time, the prominence rises, and when there are crunch situations or short deadlines, these are the people who become crucial to make the project successful. So you would see that eventually the person gets a lot more visibility and is able to move faster in the career. And that's why the second tip is pick up non-core skills. It's very important. Third problem is data cleaning. A lot of people are caught off guard. They expect that when they come into data science, either report creation or visualization, they expect data to be handed over to them. Clean, curated data. That doesn't happen. So the tip 3 is you have to sharpen your ability to handle data. And why? So here's an interesting quote from a data scientist. 80% of the time is spent preparing the data, and the rest on complaining about preparing the data. This takes it to the extremes, but it captures the essence and the sentiment of the industry. So when you look at the actual mix of time spent, Kaggle ran a survey and found out where do people spend most of the time in gathering and cleaning data. Still accounts for a majority. It's about 40 to 50%, which is unusually high. And anytime we start a project, we've seen this for the last decade, that organizations sign up and they want to start. But after having the kickoff, we realize that the data is not ready. So it takes a couple of months to even pull and get the data. The data might already be available in a clean source, but transformation of the data to make it suitable for analytics is an entirely different thing. The industry is still trying to find out how to make data engineering suitable for data science, because earlier it was geared up for just reporting, not for data science. So that's some change which is happening in the industry. And so net, irrespective of the role you're getting into, it will be important for you to pick up data handling skills. And there will be clean, there will be unclean and unsuitable data coming your way. And one other point here is, do not consider this as a janitorial task or someone else's job. When you spend time on data, actually you get a good context about the business. What is the number of products the customer has? What is the price range? When you just eyeball the data and look at it, you will be able to find out. And this becomes very useful when you're doing your analysis or creating your stories. So there are common steps in data cleaning and preparation. There are very standard tools. This is a mature space. So deduplication, standardization, normalization, and checking for quality. There are several tools which are available, and it's very easy to pick up these tools. And you can use an UI interface for working with these tools as well. It's fairly simple. But important thing is, have a mindset to handle data, pick up these skills, and budget time for it in your work. The final point under the discovery of unusual aspects is technology goes obsolete. We all know that, but the cycle is much faster in data science. The obsolescence is much faster in data science. So the fourth and most important tip for you is pick up an ability to learn new tools very rapidly. Do not wait for classroom sessions. Do not wait for a formal training course to be given to you. As long as you can just pick up and learn on the go using some online videos or by just playing around with the tool, that will serve you very well in the long run. So if you want to understand what's the tool landscape like for the data industry, this is the state as of a few months back. The intent is not to make it readable. The intent is to show that it is overwhelming. So by no means one can master all the possible tools and all the possible areas. So this talks about visualization, machine learning, data preparation, and a whole lot of areas. And each area there are dozens of tools. The industry is still evolving. Every year there are companies which sprout and there are companies which are going bust, and there are tools which get acquired. So things are changing very rapidly. Many of these have a lifespan of just a few months or few weeks at worst case. So that way, this is changing very rapidly, and even organizations are equally confused. They buy enterprise license for one tool. Next year, they find that there's a completely different tool which can do a lot more things. So they are also deciding in terms of what to purchase and for how long. And there are a lot of changes in terms of what is available within the enterprise. So even if you've learned a tool at school, that tool may not be available in your enterprise. So you need to have the agility to learn a new tool which your IT department will provide. And the important point to note here is the tool really does not matter. It's the skill and the application of skill, like we've seen earlier. So as long as you have an ability to learn new tools very rapidly and apply the skills very well with that tool, you're covered. So let's take an example. Under visualization, if you're looking at what are the options available for you. So one axis is the flexibility. What kind of an output are you trying to create? Are you satisfied with something out of the box standard template, or you want more flexibility to create something completely new? The second axis is the complexity. What level of complexity are you willing to take? Are you looking for, again, a UI drag and drop interface? Or are you looking for investing time in doing something with programming and a lot more intensive from scratch? So based on that, there are several tools available in visualization. This is a sample set. You have two clear regions here coming in. One is the plug and play, limited flexibility and low complexity, but just gets the job done in certain templates. The other one is code-based, high complexity, but very high flexibility. So examples of tools like Timeline, for example, is a tool where you can just connect it to a spreadsheet and just pull it out onto a timeline kind of an interface. And very easily you can have this visual created. But if you want to change some of the years and the way it is represented, it's not possible. So that's one thing from the plug and play side. And the second one, there are moderate set of tools like Excel, Google Sheets. So these are tools which fall right in between. They don't need coding and they don't have that severe limitation like these other tools. But they still have some moderate complexity and moderate flexibility. You can use it for very simple purposes, just like looking at tables and doing some simple pivot tables. Or there are people who have implemented AI within Excel sheets. So that possibility is there. And when you look at the code-based tools, D3 is an example of tool which has immense power, but the flexibility is very high. But the learning curve is very, very steep. So you'll have to look at which tools are relevant for you. So look at your what you're willing to invest, the amount of time you're willing to invest, what flexibility you need, and what tool you have access to. Is it paid one? Which ones your IT teams have license and options for? So to recap this section, we have looked at 4 tips for invincibility in a data science career. Number 1, master the application of knowledge. Number 2, learn non-core skills. Go beyond your core competence and learn some other skills. Third, sharpen your ability to handle the data. And 4th, pick up an ability to learn new tools very rapidly. With that, we'll move on to the final section. Again, quick pause here. We will take some, let me share the next poll.
Also, while this poll is sharing, I want to encourage all the students to start piling in with some questions, because we are going to take some questions when we're done.
Yeah. You should see the poll. And here, the question is, how do you think COVID-19 and the recession will impact the industry? Negative impact, either big or slight negative impact, no impact. And the last one is for the optimists, who think that there's going to be something positive coming out of this for the data science industry. And interestingly, I see a lot of optimists here. Wow, that seems to be the majority so far. So overwhelming majority of optimists here. So let me end the poll now, and you can see the results for yourself. So 66% feel that there will be a positive impact on data science. That's pretty impressive. Let's see what is the real state. That's the final section which we'll talk about. What does the recession mean for the industry and for the jobs? Firstly, we see this in the news every day. We're still in shutdown, and the impact on the US economy is nothing like anything we've seen in the last couple of decades. So this is going to be a huge impact, the biggest impact since World War II. And this is a projection as of this month. We don't know how it's going to change in the coming weeks. This has led to a lot of lost jobs. over 26 million lost jobs. And all of this has happened in just 5 weeks. All the jobs created since the last Great Recession are already lost, a lot more than that. And the rapidity of the loss, earlier it used to be 6 months to 12 months to feel the impact. Now within 5 weeks, all of this has happened. And it's still continuing. That's a worrying part. So what does this mean for jobs in data science? McKinsey came up with this analysis. They looked at the vulnerability of jobs by industry, and they're looking at the earnings. And a third aspect is the level of qualification. What is the extent of bachelor's degree plus is needed for some of these industries? And this is the result they've presented. So there are industries which are in the bottom right side of the quadrant. Low pay and high vulnerability, and accommodation, food service, transportation, and unfortunately, this is a segment which has lowest wages and has the lowest educational attainment and is the most hard hit. Things have panned out extremely unfortunate for these people, whereas for data jobs, they are in the relatively safer zones, like top left, where you have the data and the specialized professions, which are less impacted, and they have professionals who are much better qualified with higher earnings. So why is data important in the current scenario? And many of you seem to know the answer already. So we look at 3 categories. Public health, what are some areas data is helping tackle the challenge of COVID-19 and the coming recession in public health? In enterprises, the enterprise space, and third one is in communities. Under public health, we've been reading about it quite often. So data is crucial to track the complete patient life cycle, from testing, treatment, recovery, hopefully. And it's useful for contact tracing, the vulnerability of people and those who have been in touch with other patients. And also it's important for predicting the infection rates. This is something we're seeing almost on a daily basis, the governors presenting the model results. It's that important, where states are using the models to decide how they're going to be lifting the shutdown in phases. And what is likely to be the infection rate, the doubling rate, and all of these are model parameters which until a month back, which only data scientists are using. Now it's being talked about in national television. So there's one interesting example of how data is helping with public health. Kinsa Thermometers is a company which manufactures thermometers, and they have this online, where the thermometer temperature readings are pushed online. And by studying the thermometer readings across the entire set of counties in the US, Kinsa was able to identify the rate of progression of COVID-19 last month. And they were able to call out patterns 2 weeks earlier than CDC, purely by using this public data, which is anonymized. And they started correlating this with other parameters, such as like when was the shutdown imposed, when were schools closed, and what difference does it make to counties which took an early decision. So this shows the difference between Santa Clara and New York. And the line you see there is the thermometer reading, purely looking at the temperatures. Is there an unusual illness in a particular county, and has it gone up, or is the unusual illness coming down? With that, you're able to see that Santa Clara took some early decisions. State of emergency was declared, work from home guidance, all of these by a few days. And that has made a difference in flattening the curve even more and earlier compared to New York. So this is an interesting example from data on how you can call patterns. Second, from enterprises space, data is going to be extremely crucial to ensure cash flow and liquidity for companies. During the recession, that's the most important thing, which executives are watching every single day. And data can help you forecast these numbers, or help you take measures to maintain a healthy cash flow. And with workforce being completely remote, how do you ensure effectiveness of employees? How do you ensure collaboration? And how do you ensure productivity? So data can tell you where our employees are stuck, what are the kind of applications which are slow, and where you need to pay attention. So it's very useful, and there are several areas where organizations are already using data for making remote work effective. Third category is supply chain and logistics. Last month, we saw massive disruptions starting all over the world, and it's still continuing. How is your raw material and supply chain impacted? And what are the logistics aspects you have to take care of? And with data, you can start identifying the bottlenecks. which point exactly is it stuck, and when is it likely to move. And you can also start doing a lot of what if simulations. Assuming I have fewer people reporting to work today, what will happen to my factory production? So looking at which customers should I serve if I have a shortfall of capacity, and which products should I sell, and which services should I offer to keep my margins high. All of this, you can make it scientific and let your managers plan ahead of time by using data. Third category is community. Data has been helpful to check the effectiveness of shutdown from a public governance standpoint. And it's helpful to understand behavioral shifts. What are some of the new patterns of consumption which are likely to continue in the coming weeks or months? What does it mean for businesses? When you look at Google Trends, you can start finding out what are people searching for. Are they ready to come out? Are they ready to buy certain stuff? So with that, you can start understanding about the community. And finally, it can also help you understand what are people most concerned about during COVID-19. And New York City has this 311 number, which lets you call in and share some public civic complaints. If you're wondering, what is the biggest concern reported in the last couple of weeks? Any guesses on what you think it is? I'll pause for a couple of seconds. I want to hear what you think. What is the topmost complaint from people in the last couple of weeks before I show you the answer? Okay, any guesses? Okay, so given the time, I'll go on. So the topmost complaint is social distancing. So people have been calling in and complaining that there are groups of people gathering, or the neighbors are not maintaining social distancing. And until a few months back, the noise and other complaints were dominating, whereas now it's predominantly social distancing in all parts of New York. So those were use cases and the uses of data in this situation and in the future. Now, this is the final slide. How do you stay relevant and grow in your career path? These are some useful tips for today, and these are some tips which will help you in the longer run as well. Number one, read and write on data science. There are extremely good materials available, and a lot of this is public and freely available. So read through that and then keep yourself informed. And if you have a flair for writing, or even have an interest in trying it out, do open your account and start writing on your blog, on Medium. There are enough sources and there are enough people willing to consume it. So this will make sure that you clarify your concepts for yourself. And when you put it down on paper, it makes it, you'll be able to digest it even better. Second, do your own data projects. Even if your organization doesn't have very exciting projects, there's nothing stopping you from picking up public data. There's enough public data. For instance, COVID-19, there are whole lots of data sets available, public domain, and refreshed on a daily basis. And there are several other public data sets which every government and institution is making available. Whether you want to build models from it or create visual stories, do your own data projects, whatever fascinates you. And with the skills that you put to use, also enter competitions. If you fancy machine learning, Kaggle has a lot of great ML and AI contests. And if you want to do visualization, Information is Beautiful is a great contest, annual contest. And there are several other hackathons which keep regularly running. So compete, learn from the other participants, collaborate, and apply your skills again. And that's one of the best ways to learn. And finally, anything that you do, whether you're writing, doing your own data projects, or competing, or creating your public repositories, maintain a public portfolio. Resumes are kind of dead. Like, people look at it just for completeness. But if you really want to stand out from the crowd, you will have to show initiative. You'll have to demonstrate your passion for data by doing stuff and creating your public portfolio. But a lot of people start ambitiously and they stop with one blog, or they stop with one repository, which basically stays dormant throughout the year. So when you have a public portfolio, two things are key. One is quality, the kind of work that you take up and do. Make sure it is aligned with your interests. And second, consistency. Pick up, it could be weekly, monthly, or quarterly. Define your schedule and maintain it at that level of consistency. Only then it makes sense when you share it with the public. So those were the tips for growth in your career path. And today we've looked at those the 3 areas of learning. One, you have understood the value of data science for organizations from these examples. And I hope these 4 tips which you learned, these are some things which professionals also find useful. People who are already in the industry and have spent many years, these are things that they're trying to hone and strengthen. So I'm sure this will be very useful as you start your career. And third, despite COVID and the recession, stay strong. And this is a skill, and this is an area where a lot of people need support. One is the job aspect and the job security aspect of it. The other thing is this is something which you can use to serve and support communities, support companies. So put it to good use. With that, thank you for listening in. You've been a great audience. Thanks for all the participation.
Wonderful. Well, thank you so much. Dr. Pawlowski, we have time for a few questions. Go ahead.
Well, I don't have any questions because
Well,
Vanessa answered them all, but thank you. And I hear this overwhelming applause going on in all our little sheltered in place students in their little worlds. I hope everybody enjoyed the talk, and please type your questions into the question box. The first one here is from student Jocelyn. She's in the field of, well, she's actually studying interaction design and web applications. And she's asking, what data topics would you suggest would be helpful to obtain in order to boost one's experience in data within that context?
So for interaction design and web applications, if you're looking at areas within data where you can demonstrate and where there's a demand for it, data storytelling falls right there, where you're bringing together the design skills with the domain and creating an interface for the user. So user-centered design, interaction design by designing the right interface and improving the user experience. So that is an area I would suggest. And there are several courses on how a data story is different from a visualization. The courses talk about that. And there are certain skills on how you can create narratives. What are the different storytelling formats? So if you can strengthen your skills in data storytelling and also keep your eyes open for the domain knowledge and a familiarity with playing around with the data, I think that would be very useful in the career.
Thank you. And there was an earlier question about how do we check the quality of data? This goes back a couple of sections in terms of what you were talking about.
Sure. So data quality falls broadly into the data engineering space. And there are some of the points I'd mentioned, which is deduplication, normalization, and checking for missing values. That's a common problem you see, that not all data fields are filled in. There are a lot of missing values. And at times the formats that are wrong, the date formats are wrong across countries. So these are some common challenges you would find even in clean enterprise data sources. So the ways to check these, there are several tools, and there are some automated routines where they run and check. If it's a date field, it automatically checks for validity. So that way there are some automated routines, and there are also tools. For example, if you're looking at public data, Google Refine used to be a great tool to check and play around with the names and clean the data online. So if you look up tools for data quality, that's one route I would suggest. And second, these the techniques I mentioned, deduplication and normalization, and some of these are also ways to improve and check and improve for data quality. The first thing to do to start with data quality correction is browsing through the data. If it can be opened on an Excel, just open it, look at summaries. What is the lowest value, highest value, what is the range, and is it in line with the business expectations? So that's the way you start by checking quality.
Thank you. And then there was one, I think, that was related to the earlier discussion on prospective jobs for data scientists. Wouldn't data scientists be the ones in the industry to interpret the results of the recession for businesses going forward, as an example of an application or a need for data science?
Yeah, very true. Yes, like the examples we saw towards the end, data scientists play a critical role in understanding how are the trends changing and how is the recession going to be hitting the business. It may not always be by model building. A lot of people assume that when we say data scientists and recession, they think forecasting, say, cash flow, or forecasting the consumer demand. is the first thing to do. In fact, in this situation, forecasting models will go wrong because this is kind of a black swan event which is unexpected, and then the patterns have completely changed few months back to now. A simple time series forecasting model, for example, won't be able to predict this pattern. It will be actually confused by the sudden dip. So the place to get started is analysis to find out what is like statistics and analysis, like the example we saw with forecasting, finding out what is relevant in that scenario. And now that we have, say, a month of data in the post-COVID scenario, this might be sufficient data to start modeling. But beyond that, what if simulation? I explained the example of assuming you have a lower turnout, lower number of employees showing up today. What should you produce? And optimization, if you have a shortfall of raw materials, which of your products should you produce to improve your margins or keep the margins high? So those are some what if simulations. Those are also cases like beyond forecasting, you can put analytics to good use during a recession.
Oh, here's a good one. I really want to know the answer to this. Andrea asks, what should the average person know about data science? For example, what would you like to see taught in schools regarding this topic?
That's a great question.
Yeah, I think so too.
So the first aspect about data science is not about, it's not machine learning, or it's not even visualization. It is data literacy. What is the use of data, and how does anyone get started with the data? So basic aspects of what you can do with simple computations with data is a place to get started. And particularly in schools, when you teach students on what is the power of data and educate them on basic data literacy, what data is relevant where, and when you have say text data, what you can do with it, the possibilities, right? If you have certain pictures, a feed of pictures, what can you do with that? If you have a lot of audio clippings, what can you do with that? And how do you go about with simple data? Like you can train students to collect their own data. Say it could be the time logs, or it could be any of their the school marks or grades, and then you ask them to play around with that and come up with simple summaries and ask them to present the results in presentation. We've tried that with a couple of people, and we've seen the results have been fascinating. So you'll be underestimating what people can do when you give them the basic literacy with data. I think that would be the first starting point. And interestingly, not just for schools, even for adults, for people who are not from the data background, this is a great starting point. And I am of the strong opinion that whether it is data or AI, you need to educate people first, and for them to make an informed choice. That's most important.
I would love to see a workshop on data storytelling.
Wow, yeah.
One more question.
Just one more? Okay, yeah. I don't know which ones. Do you have any tips for people working outside of the data science field who want to bring data science tools into their workplace? And how do you advocate for those tools to your boss?
Yeah, that's another great question. So this is, how do you sell data internally? And this is something which data champions within enterprises, they play an active role on propagating and advocating for it. So the last part of the question is easy. I'll talk about that first. How do you advocate these tools to the boss? Pick up examples relevant to the industry. Like some of those we have spoken, and there are several other public examples. Pick up those and show how it has delivered a return on investment. It's not just interesting of fancy visuals, but if you can put a business ROI figure to it and say that this business benefited, either the revenue went up or the cost saving happened, that's one way which makes business folks pay attention to. That's a starting point. And then the other part of the question was for people working outside the data. Yeah, I think the data science tools. When it comes to tools, if you're really starting and the company is not convinced with, say, purchasing a tool, I would suggest start with open source tools. There are great tools out there, whether it is for analytics, visualization. There are several fantastic tools. Start with that. And the only thing is you have to convince your IT team to set this up on your laptops or your machines. And thankfully now with the awareness, it doesn't take too much of a selling. Open source tools where you don't have to pay for it, you'll be able to install it. And with that, you should create some results with your internal data and show that to your superiors and say that this is what we have done with our own data when we use open source tools. And that can move the needle and convince people.
Do you have any names of actual tools? We have a couple of questions about free resources for becoming self-taught.
So for machine learning, R is a great starting point. R and Python are great starting points, and statistics, machine learning. And for data visualization, so if you have a programming background, D3 would be great for visualization. And Excel has a lot of capabilities as well. Excel and Google Sheets and Google Charts. Those are starting points. And apart from that, I'll be sharing the slide deck. Some of the tools I mentioned, the plug and play zone, they are also free tools. Yeah, I think those are good starting points. I can share a list after the session.
One last question, Lily.
Oh, okay. Is there any platform where we can find business problems posted and we could start our own data project on the same, on that topic?
Yeah. So platforms where problems posted, look out for the online hackathons or the competitions. For example, Information is Beautiful awards. If you search for that, you'll be able to find out they run this annual contest where you can submit it, but that doesn't have a problem statement. You submit entries. But there are others, like recently there was a World Bank challenge where they gave some data and they asked people to submit entries. So similarly, there are several in the forum. There is a data visualization group based out of New York City. You could join that list. And for people from the machine learning side of things, Kaggle is a great starting point. They have curated, prepared data and great problems from the real world, which you can pick up and build models on.
We got to take this last question, okay?
One more. Such a good one.
Because it's the last one, we got to do it.
Yeah.
What are some of the recent innovations in data science, either before or during this pandemic, that you are excited about?
So within data science, the power of advanced techniques like AI, deep learning is something which I'm very excited about. And so one example of this is image recognition. I talked about satellite imagery. An extension of this is when you can detect people, and in the days to come, social distancing will have to be maintained. So one great application of AI in this area is when you look at the camera feeds, AI can detect whether two people are maintaining social distance. Mm-hmm. And while there's also a privacy angle to it, whether is it kind of getting into the personal space, but given the reality we are in, the health situation we are in, organizations will have to monitor for social distancing within their workplace. And say retail shops will have to do that same thing. So AI can be used there, where you can just pass your camera feed to the AI model, which can work out the 3D kind of the locations based on the feed and tell which are the violations happening in real time.
Terrific, thank you. I guess that's it.
Right.
Ganesh, thank you so much for joining us, and thank you all for joining us as well. Maybe we can do this again in real life someday with proper social distancing in place.
Yeah, thank you, Dr. Pawlowski. Would love to be back and hopefully in person next time. Yeah.
Oh, it'd be wonderful. Thank you. Good night, everybody. Thanks
Good night,
for
everyone.
joining
Thank you.
us.
Bye, everybody. And again, good night on behalf of my Colloquium and for my Colloquium students. Again, go ahead and post your reflections. I'm really looking forward to see that. There will also be a survey sent out to you, so please take a few minutes. It's only 4 questions. Take a few seconds and return that so that we can, again, continue to improve this session. And with that, be well, stay safe, and we'll see you next time. Bye-bye.
Thank you, Connie. Thank you.
Good night. Bye.